thank you, Doug, for that introduction. I'm not sure. That feels like my first kindergarten report card, you know, energetic being used strictly as a euphemism for various pathologies. Good morning. I'm Bryan Cantrell from Sun Microsystems. I am, I guess, the problem child, at least 2009, for which everyone has my profound and profuse apologies. So this morning I'm going to, and there's actually not a slide up here because this is going to be a very demo-intensive presentation. But if you wondered what presentation you've wandered into, this morning I'm going to give a presentation on visualizing DTrace. And before I get started, because it's kind of implied in the title, if I could, and I'm not doing this for purely self-aggrandizing reasons, but how many of you have heard of DTrace? How many of you know what DTrace is? Okay, that's great. This is the pinnacle of the fame that I will ever achieve, is that a room full of fellow super nerds recognizes the technology that I developed. That's about the end of the line for me. That's great. How many of you actually have used DTrace? That's terrific. How many of you have used DTrace to actually solve a problem? Okay, wow, a smaller number of you. Okay, so just a quick aside, DTrace is a workhorse, not a show horse. So, I mean, it's great that if you've seen DTrace and every once in a while, I love DTrace. Well, have you used it? Well, no, not really, but it just seems great. You should use DTrace to solve your problems. That's what it's designed to do. It's not designed to just kind of be cool or recognizable or what have you. It's designed to actually solve your problems. And indeed, you will find that your disposition towards DTrace changes the first time you actually use it to solve a problem. And those of you who've actually used DTrace to solve a problem can attest to this. And I had this experience myself in developing DTrace. The first time that DTrace saved my ass was it's a fundamental shift that you have from, wow, this technology seems interesting, it's something to play with, to, wow, this technology is something that is really essential to my day job. And if you are a systems administrator and you've got DTrace on some of your systems, be they Mac OS X or Solaris or FreeBSD, really encourage you to actually use them in anger. Use DTrace in anger. That's what it's designed to do. And just to give you a little bit of the history of DTrace, the reason that DTrace is effective for solving problems, or we believe anyway, is because we actually designed DTrace to solve our problems, which seems like a kind of a stupid thing to say. But the reality is there's a lot of software tooling out there, a lot of software infrastructure out there that was not developed by the people who intended to use it. And I think that the best infrastructure, the best tools in particular, are always developed by those who actually need them. And a lot of you have a kind of tools groups or people focusing on tools research or what have you. If they're not actually using the tools they end up developing end up being show horses, not workhorses. And we very much needed DTrace to solve our problem. What was our problem? Well, I came to Sun 13 years ago to work with Jeff Bonwick in the Solaris Performance Group, and the problem that we had was pretty simple. We didn't know why the system sucked. And worse, the sucking is not some persistent phenomenon. The system would start sucking and then stop sucking, which on the one hand, it's like, all right, great, the system no longer sucks. But if you're actually trying to understand why the system sucks, that transient nature to the problem is absolutely brutal. And this was hit home for me when I first came to work for Sun, 1996. We were looking at a benchmark rig. This is actually in the winter of 1997. And we had just released a machine called the E10K. Now, I don't want to see a show of hands on the E10K because, let's face it, we all have very mixed feelings about the E10K. There's a lot of love and some pain with the E10K. But E10K was a very exciting machine. It was a 64-processor machine, true SMP machine, and there were a lot of great things about the E10K, really essential to Sun's rise, maybe fall, but certainly rise in the late 90s. So we had just shipped the 64-processor machine, and I was looking at a benchmark run. These guys were doing a huge benchmark run up in Beaverton, Oregon, and they had a serious sucking problem. They're running this benchmark, and the benchmark would run like a champ. And then all of a sudden, it would stumble, and the sucking would start. And it would last like 4 minutes. I mean, the system would be frenetically sucking. And then it would stop. and the system would go back to running like a champ. And they could see, based on the throughput they were getting during the periods in which it was running properly, that we were on track to break the world record for this particular benchmark. But the periods of sucking was the difference between first and worst. They had an unpublishable number with these periods of sucking. They didn't understand what was going on. So they got us involved in Solaris Performance. And at this point, I had never seen an E10K. They're just too expensive. We didn't have one in our lab. And these guys didn't have one E10K for this benchmark. They had 5 of them. These are 5 E10Ks racked out, 64 processors, 64 gigs of DRAM. It is telling to me that 12 years after the fact, the specs of that machine are still non-trivial. Your laptop does not have 64 processors and 64 gigs of DRAM, not yet anyway. But those machines, you can imagine in 1997, those machines were Goliath. They were huge machines. And it was one machine, one 64 processor E10K to actually run the benchmark, 1 to run the Oracle database, and 3 to drive load onto it. And so we started looking at this machine, and the tooling that we had was incredibly primitive at the time. At the time, actually, the only real tooling we had was a tool that Jeff Bonwick had developed in Solaris 2.6 called Lockstat. And if you use Lockstat, Lockstat was kind of a shard of light into pitch black, really just a shard, though. And we were having to use it to try and understand the system. And it was really difficult because we couldn't really explore hypotheses. We could get some amount of data out of the system, but to actually explore a hypothesis, I had to write a custom kernel module and throw it onto that machine. Now, if you have an E10K or had an E10K back in the day or know of an E10K, or if you've got a big machine today, you know that booting is not a real strength. Those machines took kind of a while to boot. At the time, they took about 90 minutes to boot. So loading a kernel module onto the machine is not really tenable. So what I was doing was I was dynamically loading kernel modules. I was dynamically substituting kernel modules that were being very dirty about the way they were instrumenting the system, and hoping to God that I got it right. Because if I didn't, the system would panic, and I would have like an hour and a half to go figure out why I'm such an idiot. And everyone could kind of twiddle their thumbs while I generate a new kernel module that fixed whatever bug we just run into. And the progress was very, very slow, very frustrating as a result of doing this. So what was the problem? Well, as we were digging deeper and deeper in the problem, it was clear that we were going quadratic in the networking stack. Order of n squared, actually, as I recall, it was like order of n to the 4th in the networking stack. And we found an easy way to reduce that to order of n squared. Great. And we kept digging and digging and digging to understand what the problem was. And as we got deeper, we would discover, for example, we were order of n squared, or order of n to the 4th. But this is a list that should never have more than like 4 things on it. So why did it have 1,000 things on it? OK, well, yet more custom kernel modules. Dig, 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 dig. And all along, we're getting deeper and deeper and deeper and deeper. And my assumption the entire time is that when we get to the final answer here, it's going to be deep in the bowels of the networking stack. There's going to be something imperfect, suboptimal about the implementation. We're going to switch that, and that's going to be the problem. And boy, was I wrong. Because when we got to the end, when we finally figured out what the problem was, what was the problem? The problem was that the machine had been misconfigured. It had been misconfigured to act as a router. Etsy no default router was not set. And they were seeing sporadic router failure elsewhere in the lab. Router would pop, and the world's slowest, most expensive router would volunteer to start routing packets. So the benchmark machine would furiously start routing packets between all these other machines. And it sucked at being a router. You're not a router. Do not route packets, please. But why was this so horrifying? Because why was this set? Or why had they not set it correctly? Because weeks prior, when they were trying to get things working, only this machine had a route. They had another router problem somewhere else. And they had effectively configured the machine to act as a router, albeit briefly, and forgot to undo that. This is a mistake that anyone could make. This is an entirely reasonable mistake. The fact that the symptoms of the problem were so far removed, the fact that it took 2 weeks of quite literally around the clock, around the globe, kernel expertise. You as a customer never could have assembled the expertise that we were able to summon on that problem. And it was bone-chilling that any customer could have that problem. And we realized that the sucking was a serious problem, and the ways that we had of resolving that were completely down the wrong path. Because all we would give you were these kind of bean counters, kind of happy or sad counters. I'm not a huge fan of happy or sad counters because usually if a counter is telling you you're sad, you're like, I know I'm sad. I wouldn't be looking at you if I weren't sad. I don't need to know that I'm sad. I need to know why I'm sad. And this idea of custom generating modules to throw them on the machine was a non-starter. But why was I having to do that? Why was I having to custom generate modules? Because these modules were not written to debug every possible amount of information. Right? Look at the way we develop software. If you want to see software, how do you see it? You add things to your code that say if logging is enabled, or if debug is on, or if you want to see me, I'm going to syslog, or I'm going to store something to a ring buffer, or I'm going to emit some datum, right? And the problem is that boils down to that if conditionally emit datum, that boils down to a load, a compare, and a branch in terms of the microprocessor. And that costs. There's no way around that. And you can't possibly, moreover, anticipate every portion of your code that needs these. Right? And if your code were covered with these things, your code would be too slow to ship, even if they were not enabled. So we realized that we had to take a fundamentally different approach. And what we need to go do is be able to safely, dynamically instrument the system. And we needed to do that in such a way that we could ask arbitrary questions about the system, gather arbitrary data. So one of the first things that we discovered in starting to develop DTrace, so Mike Shapiro, Adam Leventhal, and I started to develop DTrace, or Mike and I initially set out. We added Adam to the team about 6 months later, in the fall of 2001. And one of the first things we figured out was we need a programming language. And I assume many of you if you've obviously heard of DTrace, so you've seen DTrace demoed or what have you. I won't actually, well, maybe I will actually just show you what it looks like. Fortunately, I've got this is my Mac. It's enormously liberating that I can show you DTrace on a platform that I did not develop myself. So if I just run DTrace without any arguments, I see this kind of Unixy style help message, which is normally fits within the 80 columns that God intended, but is only wrapping so you can see the font. I want to make that absolutely clear. That I feel like I, and perhaps we in this room, are the last on the planet to defend God's intent of 80 columns. But I will defend it to the death. I want you to know that. It was heartbreaking to me when a fellow engineer, who will remain nameless because it's just too heartbreaking to name him, started using one of those newfangled mail clients. Not Mutt, thank you very much. And I would still be using Elm if Elm could, God damn it, if Elm were actually compiled large file aware, I would still be using Elm. I would be one of the Elm dead enders. But anyway, started sending me mail with embedded control M's in it. So my mail reader, of course, is embedding all of these horrific carriage returns that make it impossible to actually read his mail. And it's pretty sad. Anyway, 80 columns of death. So this is 80 columns. You just can't quite appreciate it here. If I wanted to actually enable some probes, I'm just going to, we'll do every system call, and we'll just we'll actually just trace the exact name. Let's do that. So the programming language aspect of DTrace, I hope people can see that. Maybe you can't. Can folks see that in the back? OK, great, thank you. So the programming language aspect of this is that you want to attach arbitrary expressions. And this presentation is not meant to be an introduction to DTrace, so I'm just going to kind of fly through this. But this is the kind of the arbitrariness here, the arbitrary expression, which is a critical observation in DTrace. The fact that we, and again, it wasn't that we made this observation in the abstract. It's that we realized we needed this when we went to go use this thing to actually solve real problems. So if I just run that, for example, what I'm going to see is as every system call is executed, I can see who is doing what. And of course, it's all DTrace and terminal. Which brings us to a very important second observation from DTrace that, again, was not reasoned about a priori, but rather figured out as we started to implement it and started to use it to actually solve real problems. So what we see here is DTrace and terminal. Terminal being Apple's terminal here. So we see some selects, reads from terminal, writes from DTrace, and so on. So what are we seeing here, of course? We're seeing all the system calls involved in writing all this crap out to the screen. Right? We're seeing ourselves. And if you were to do the traditional Unix thing of dtrace, pipe to cut, pipe to sort, pipe to unique minus c, pipe to sort minus n, and so on, you come to the conclusion like, hey, good news, I figured out what was going on with the laptop. DTrace was murdering the laptop, right? And of course, that's the wrong conclusion. This is an example of what I would call, and I don't know if Bill's in the room or not, but this is what I call the top problem, right? You run top. What's the top process? Top. It's like, good news, man, I found the problem. I'm the problem. Or as actually one admin says, no, we run top, and the top 7 processes are 7 different tops from 7 different admins logged into the box trying to figure out what the hell's going on. Which is probably more apt. And the reason, by the way, the top suffers from this problem, the reason you would see this here, is the same issue, is that the amount of work that you're doing is scaling with the amount of data. Right? The amount of work that top has to do scales with the number of processes. You've got 8,000 processes in the box. Top has to do 2x the work if you just had 4,000 processes. Right? Of course, the day that you want to understand what the hell's going on in the box, you're more likely to have 8,000 or 4,000. More likely to have 8,000. So when you most need top, it is most likely to consume more of your CPU, which is a problem. Not to denigrate top at all, but I guess it worked out that way. So we did not want. We realized in DTrace that we wanted to get out from underneath this problem. Actually, that's an overly romantic way of expressing it. I'm actually this implies that because we kind of saw this problem a little bit after the fact. The true genesis of aggregations in DTrace, which is what I'm kind of leading up to. Actually, let me show them to you, and then I'll explain the true genesis. So what we realized we needed to do in order to get out of this problem is we don't want to trace the exec name. What we want to do is aggregate on it with this @ notation. And I'm going to take the aggregating action to count. When I run this now, I don't see any output. And what we're keeping in the kernel is just a little table of exec name and count. That's it. Even better, we're able to keep these, because we call these aggregating functions. These are functions in which you do not need to see the entire data stream in order to be able to derive the result. Median is not an aggregating function. Mode is not an aggregating function. However, doing a count, for example, is. And why is that important? What I'm able to do is keep a table of these per CPU. And then I can aggregate them together in userland. This scales. Right? You don't have any, because one thing you do not want to have in any sort of instrumentation framework is contention on some global table to increment a variable, right? Because you will quickly become the problem. So if we Control-C that, we see what is and again, if this were only 80 columns, I'm actually considering making this smaller and then going to, God is angry here. I can just feel it. I'm going to be punished later. So I'm hoping you can still see this because this just does not feel right. All right, there we go. OK, order has been restored into the universe. And we can see what is truly going on in this box. Terminal and DTrace are really not the issues. Right? I've got a VMware image that's crunching away that's definitely doing a lot more work than either of those guys. Right? So that table is a much more concise answer. Now, I say that this is a bit of a revisionist history in terms of explaining how we developed aggregations, because the real truth of the matter is that aggregations were developed for a much more emotional reason. And that is, I told you about that lockstat utility that Bonwick developed. I was hell-bent on having the rare and unique pleasure of ripping out a bunch of Bonwick code. So Bonwick is much more, for those, Jeff Bonwick is better known as the inventor of the ZFS file system, superlative software engineer. I've worked with Jeff for many, many years. Jeff is much more predator than prey in the software landscape. Jeff has ripped out much, much more code than code of his has been ripped out. Indeed, I think I'm the only person to really rip out a substantial amount of Bonwick code. And I was hell-bent on doing it because what I wanted to do, in terms of lockstat in particular, I wanted to re-implement lockstat. I wanted to re-implement the way that lockstat instruments the system, which, by the way, uses dynamic instrumentation. It dynamically instruments synchronization primitives. I wanted to re-implement that as a DTrace provider and re-implement the lockstat command as a DTrace consumer. And then I could take this body of work that he'd done in the middle, and I could rip it out, which is what I did. But I needed to invent aggregations in order to do it, because a lot of what he was doing was effectively an aggregating operation. But he wasn't just doing counts. He was doing something more interesting. He was actually looking at the distribution of data, which we can also do with aggregations. And so let's get a little bit adventurous here. what I'm going to do is, with my apologies for doing it on the command line here, I'm going to set a thread local variable to be the timestamp. And then on syscall return, if self at ts is set, I want to aggregate on, let's do aggregate on the probe func, which will be the system call name. And I want a power of 2 distribution of the amount of wall time that that system call took. Hey now. What's your problem? Is there, what's that? Where's the double equal?
No, you need a brace.
Where's the brace? Thank you. There it is. Thank you. God, that's rare. That's normally the animal brain that types that. Thank you very much. So if I run that and Control C, what I'm going to get is some ASCII art. More of what God intended. Actually, this is interesting. Look at that, huh? Yeah, that's very interesting. So we're seeing a, and in terms of visualizing DTrace, so this was our first experience developing these little @ ASCII art histograms, which, by the way, I shamelessly stole from the lockstat command itself. So if you use lockstat on Solaris, use lockstat on Solaris 2.6, that is where these histograms, the little ASCII art, the little @ notation came from. I made them a little bit wider and cleaned them up a little bit, but that's basically where they came from. And I realized, even with the primordial visualization that we had in lockstat, and then again re-implementing that in DTrace, that this visualization allows you to see things so quickly that you can't otherwise see. Right? I mean, like, just look at what we've done here in terms of poll. Now, I could have traced out every timestamp, the amount of time that we spent in poll, but how quickly would we have seen that trimodal distribution? Right? That's going to be pretty hard to see with the numbers. Right? What you would probably see is this. You'd probably be able to draw that inference. Maybe you'd pick up this guy. I don't think you're picking up this. I think your brain is going to put that in this bucket, which is to say longer than this stuff. Right? I'm sorry, don't do that. So this was our first experience visualizing DTrace. And again, this is in DTrace itself. This is not an add-on to DTrace. And if you've used DTrace to solve your problems, you use aggregations, quantize aggregating action all the time. You use it very, very frequently. Why do you use it so frequently? Because it allows you to do things that you can't otherwise do. It allows you to engage your visual cortex. The visual cortex. Very powerful thing. Thank God we're chimps at the end of the day. And we can leverage the fact that we want to seek food and mates and so on to actually, I guess actually maybe using DTrace often is just a more elaborate way of seeking food. Certainly, probably not mates though. I don't know. You have to let me know on that one. If that works out, definitely keep me posted. I think my wife would say that DTrace is not an aphrodisiac, but I don't know. Try reading the manual aloud. Try doing that to your spouse or loved one. Leave that. Let's just see if that works. Let me know. But it will help you seek food, I think. But that's about it, maybe. So this was a real eye-opener for us. And by the time we got DTrace, I would say roughly done. Not that DTrace is completely finished. But we started on DTrace in the fall of 2001. And our initial integration to Solaris was the fall of 2003. Shipped to customers in early 2005. Open source in early 2006. So by 2005, mid-2005, DTrace was pretty well baked. I was no longer tracking inside of Sun when people would use DTrace to solve problems because we were using it all the time to solve all sorts of problems inside of Sun. People had used DTrace a lot to solve problems outside of Sun, which was, again, a real eye-opener for me. I think that it was the first time, DTrace was the first time that we in the operating system were able to deliver really good news to you as opposed to just less bad news. Right? If you think about it, like, what can an operating system do? Once an operating system basically works, it can really only not screw up. Right? It can only not panic, not corrupt your data, not suck, what have you. Right? You don't come in every morning and be like, oh, thank you, operating system, for having run through the night with such low load, like you're great. You're like, no, screw you for panicking, right? But with DTrace, we could actually give you some good news in the operating system. We allow you to actually solve your problems, which has been enormously empowering. But that was the state of DTrace in 2005, 2006, and I wanted to go do a lot more. I wanted to go, this to me was the just a very, very tip of the iceberg in terms of what we could do to engage the visual cortex to solve a problem. And the other thing that I wanted to deal with that I was a bit uncomfortable with, or just uncomfortable with, but a reality of DTrace is that this arbitrary power implies the programming language, right? And some people, oh God, not another programming language. It's like, well, you're not writing a program exactly, and this is roughly, I mean, it's very kind of awkish style syntax, right? So it's an easy language to learn, and I think that for folks in this room, it would be no problem to pick up D, which is the language of DTrace. By the way, a little story on that, by the way. So you may look at this and say, like, God, this looks a lot like awk. And speaking of other things that God intended, we were directly inspired by awk. I assume that we're all systems guys here, right? I'm not system guys and girls. We're not. I don't know. I assume that no compiler folks snuck in here. I know that they were checking at the door. They had a pretty serious security detail. They were asking you the difference between various parsers and then taking you out back if you actually knew the answer. So I assume that everyone LALR parser. I don't know. I took my compiler class too many years ago. I don't give a shit. So I assume that's the room here, because you know what? As systems folks, we love awk, right? I love awk. What? Hey, there we go. Wow, this is like a support group. I guess awk has been a little bit beaten down, maybe. Well, the thing about awk is, like, man, awk just always gets the job done, right? It does what it does. It is the true Unix philosophy. It is simple. It does what it does. It's simple, but it's very powerful. You can use it on the command line all the time. I use awk probably 3, 4, 5, 20 times a day, right? I use awk a lot. You use awk probably a lot too. And even with the presence of Perl and so on, awk still has got a very powerful place, right? Well, here's something that you probably don't know. Compiler folks hate awk. You're like, what? Hate awk? It's like hate food. I mean, you can hate certain kinds of food, but if you just flat out hate food, you die. I mean, so that doesn't make sense. But no. Compiler people hate awk. Why? Because compiler people are friggin' bureaucrats. And the idea that you could just have a variable without declaring it, you can't just have a variable. Go stand in line. Go to window 13. They're going to give you a ticket. You take that to window 5, you bring that ticket to me, and I give you a variable when I know what type it is. It's like, well, you know what? I don't know. You're a computer. You figure it out. You figure out what type it is. Why do I have to go through all this bureaucratic nonsense to get a goddamn variable? So this is the beauty of awk, the power of awk. And by the way, D, we modeled very much D on awk, and so we try to get the compiler out of your way. It's trying to help you, not hurt you, not like read you the riot act on static variable declaration. It's funny because when we actually went in front of our architectural review inside of Sun, the architectural review board, of course, I mean, it's a bureaucratic process, so of course it's packed with compiler people. I mean, come on. Come on, they love a bureaucracy. So the architectural review board packed with compiler people. So we go in front of of PSARC, and we're talking about what we're doing, and one of the guys is like, I don't know. This looks a lot like awk to me. It's like, wow, thank you very much. That's I'm flattered. Oh, wait a minute. Oh, I'm sorry. Oh, did you mean that as an insult? Oh, no. So anyway, that language to me, I mean, I think the language is an essential part of DTrace. We do get it out of your way, but it's still an impediment, right? And it's an impediment because, especially when you are asking the same kinds of question over and over again, you don't always need the full arbitrary power. So I wanted to come up with a way of visualizing DTrace that didn't require you to always be writing programs, as powerful as that could be. Okay, and we needed a way to visualize it. Well, visualizing data is a problem. I mean, we've got what God intended here, ASCII art, but other than that, I mean, in ASCII art, and boy, I mean, it kills me to admit this, but you know, I can't even believe I'm saying this, but ASCII art can only go so far. Okay, there you are. I said it. Wow, actually feels a little bit of a relief to say it. ASCII art can only take you so far. You want to be able to engage more directly, more visually, and we have had a problem in Unix, right? Namely, we are not what people run on their head, right? I mean, it's great that Mac OS X is terrific for us because finally it gave us Unix in a form factor that people could actually use as their primary display, right? But prior to that, it's like you were dealing with X or GNOME later, and nothing against those things, but ultimately it's like your mom's not running GNOME, right? or if she's running GNOME, she probably calls you a lot for support. It's like, Mom, just run Windows, okay? I'm sorry I told you to run GNOME. It was a mistake. My mom's definitely not running GNOME. And we have not had the vector to be able to visualize data. But we actually have port 80. I know port 80. I know how to talk over port 80, right? You've got the browser as a vector. So with the browser, we are suddenly liberated. We can suddenly do interesting things, provided we can visualize data in the browser. That gets a little complicated. But fortunately, around 2003, 4, 5, 6, what started to happen, the level of sophistication in the browser became much more uniform and much higher. In particular, AJAX became real, right? The XML HTTP request became something that you could count on as being in effectively every browser. And once you do that, you can actually write a program in JavaScript that actually talks to a server-side something that you can write in C, thank God. And you can actually start delivering visualization. Now, yes, I said JavaScript. How many here implement JavaScript, out of curiosity? OK, so the rest of you, I know what you're thinking. It's like, man, he had me on awk. Like, where the hell am I now? It's like, we went from awk to JavaScript? Like, am I in the right room? What's going on? So no, you're in the right room. JavaScript is actually a really interesting language. There you go. Yeah, have that one for you. JavaScript is like, it's like dynamic C. It's actually a very powerful language, and you can actually do a whole hell of a lot with JavaScript. We're very lucky that JavaScript is what's in the browser and not, I mean, there are other languages that would be much worse. JavaScript is really a very powerful language. So you've got that in the browser. You've got port 80. You've got XML HTTP request. You can start putting it together into a seamless whole. And that's what we started doing. So I'm not going to bore you with a whole creation story here. But suffice it to say that in 2005, 2006, Mike Shapiro and I decided that we wanted to go off and do something pretty radically different. We were looking at the components that we had in Solaris, where you had a fantastic operating system kernel. We felt the best available. You had really interesting technologies like DTrace, the service management facility, and then an exciting new file system like ZFS. You add all those together, and of course you think, wow, this would be a great NAS box, right? So we were thinking, I mean, it's kind of an obvious conclusion. Let's go build a NAS box. This is in late 2005. And just two quick asides on that. First of all, I don't know if you know what our market share was of the NAS space in 2005. Funny story, we invented NAS. You wouldn't know it, but Sun literally invented NAS. Right? NAS invented under Sun's roof in 1986. NFS, with NFS being the first NAS protocol, there is no NFS v1. I don't know if anyone knows why. NFS v1 never existed because they wanted to, actually it's pretty interesting, they wanted to test the ability to uprev the protocol. So they came out with v2 to make sure that everything could support future versions and could properly reject them and so on. So that's why there is no NFS v1. It was the first NFS, or the NFS v1 was only in Sun's walls. The first NFS was NFS v2. So with NFS, we invented the NAS space. So at one point in time, we had 100% of the NAS business. By the time we were asking the question, we had, wait for it, 0.3% marketing share. Now, market share, and this is the kind of thing where you got to tip your hat to IDC. It's like, wow, you've got some pretty high resolution in your spreadsheets that you can express such an infinitesimally small quantity. Like, what is this, 5 machines somewhere? Really remarkable. In fact, we lost the NAS business so long ago that the companies that ate our lunch in it have since gone out of business. So Auspex, which took all of our business, they went out of business. It's like we lost these things. We lost the game in not even the first quarter. We lost in like the first 15 seconds. The score was like 48-0, and we never got it back. So when we were looking, we wanted to go build a NAS box, realizing that we had zero share, but we had these great components that we could go build on. So and then the second thing that's kind of important for the way we developed this is we also realized that we were doing something radically different for Sun. If you've used Sun storage in the past, I'm so sorry. That's all I can say about that. But if you've used Sun storage in the past, it's been a struggle for Sun. This is something Sun did not want to use our own IP to build storage, is the reality. We wanted to go partner with everyone else out there. Well, that didn't work out so well for a lot of lot of intransigent reasons. So we wanted to do something radically different. We realized that we couldn't do that within our organizational confines. And so I had actually just read a book that I guess will go down as the most influential book I've ever read because it pretty much changed the direction of my career anyway. I read a book called Skunkworks by Ben Rich, and I would highly, highly recommend this book. So I don't know if folks are familiar with the Skunkworks. So the Skunkworks actually has been misappropriated in our lexicon, in kind of the high-tech lexicon. We use the term skunkworks to denote something without management authorization. Right? Which is like, you want to do a new project, and your director comes to you like, hey, listen, I think it's a great idea. I'm not going to be able to sell it up the chain, so let's do it as a skunkworks, which basically means, how about you work weekends? It's like, how about I don't? Let's not do it that way. that doesn't sound very fun. I mean, this is interesting, but why should I be penalized for doing something that's interesting, right? It's interesting, it's been misappropriated because that's not what the Lockheed Skunkworks was. What the Lockheed Skunkworks was the chief engineer of Lockheed, Clarence Kelly Johnson, seeing a greatest aeronautical engineer to ever live, no question, seeing new markets, in particular military applications, which he could not go attack within the existing confines of the commercial aviation business, went to Lockheed's CEO and said, here's what you're going to do for me. You're going to set up a separate facility. I'm going to take whoever I want, and we're going to go build whatever I want. And it's a tribute to Clarence Kelly Johnson that they agreed. And the only caveat was that he could only spend a third of his time doing it. He had to spend 2/3 of his time as the chief engineer at Lockheed. The Skunkworks, all the other engineers were full-time. The Skunkworks, which came as a result of that, so it was not done without management authorization. It was done with the authorization at the very tip-top of the company. And the Skunkworks developed effectively the most innovative aircraft ever built, the U-2, the SR-71, the F-117A. 3 of the most innovative aircraft ever built, all built under a single roof with a single organizational structure. We took that page, and by the way, I would encourage you to do this. Don't screw around at the bottom of the management chain. Go to the top if you've got a radical idea. And that's what we did. We went to the top of the management chain, and we, over some period of time, sold them on the idea of setting us up in our own real estate with our own group doing our own thing. And that's how Fishworks was born. And that was Fishworks was our effort to set up not just a NAS appliance, but an entire line of appliances, doing some of the things that I wanted to do with DTrace, some of the things that we wanted to do around usability and so on, and ultimately build a NAS box. We set out in the spring of 2006. We brought our first product to market at the end of last year, just almost exactly a year ago. In fact, it might be exactly a year ago today that we brought our first product to market. This is the Sun Storage 7000 series, and it's been to market for about a year. So I don't want to talk about the Sun Storage 7000 series. I really want to just focus on the DTrace side of what we have done. But if you've got questions about that afterwards, I'd be happy to answer them. So this is, I've logged into the appliance here. Something I've done is I've actually, this is a VMware image of our appliance. So our NAS box, you can go buy it if you want to spend money on it, which I would encourage you to do. But if you want to just play around with it, you can actually download a VMware image that has everything. That is fully featured. There are no license keys with this product. More of God's intentions, I'm afraid. So you've got a full software license to go use. Do with it whatever you want. You can download it yourself and play around. So that's what I've done here. I've downloaded the VMware image, and I've booted it here, and it's running along. And what we're looking at is just a status screen. This is the kind of the happy, sad metrics that I was talking about. What I actually want to go do, and actually let's go put some load on this box. Let's see, what do we want to do? Let's go create a share. So I'm going to go create a file system. We'll call this Lisa 2009 to differentiate it from the Lisa 2008 share that's already here. No, I'm just making that up. All right, we'll create that share. That's there. So if I now go over to my Finder, and if I should be able to mount this thing, Lisa 2009. And it should be true. There we go. That if I should see, there we go. So if I do this volume star, star-2. OK, so now I'm in that share. Nothing here yet. And I think I'm hoping that I've got, I downloaded the, I think it's in, I've got the Postgres source around here somewhere. Actually, I think it's a download, sorry. So what I'm going to do, there we go. So let's just do tar xvf. We'll just untar that guy. OK. That's unfortunate. Fair enough. All right, it doesn't like my. Let's try that. There we go. OK. Chug, 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 chug. OK, so now if I go to my status screen, I should see some work. I've got this is VMware Fusion, so we're doing a lot of work. It takes longer to actually do a virtual disk operation than an actual disk operation. That's nothing against VMware. They're solving a very hard problem. And so we can see here that we got my little bars kind of going nuts here, indicating that we're doing work. You may notice, by the way, these little weather icons. This is one of those things that started off as a joke that we ended up shipping. That we wanted some sort of qualitative way to express sadness. As I said, I don't like to get hung up on whether your machine is happy or sad, because you generally know. But there are times when you don't know. There are times it's like, well, this seems like I know I'm sad, so I'm looking for something else that's sad. Is this like I'm seeing X thousand NFS ops? Is this a lot or a little? We want to have some way of expressing that. I really hate green, yellow, red. Right? Because green, yellow, red, I mean, you could be, if you're doing, 100,000 NFS ops, why is that red, man? You're humping it. That's great. That's not necessarily red. That's just like doing a lot of work. So we found that the weather was actually a better metaphor, because it's like, hey, if it's sunny, that's not necessarily good or bad. It's just sunny, right? And if it's cloudy, it's cloudy. And similarly, if it's a hurricane, it's a hurricane. That could be good. It's a real tribute to the kind of nerds that we sell to, just like us, I'm afraid, that they get this box and the first thing they do is like, let's make a hurricane. I think we are all actually sadists at heart. The idea of torturing machines just does not. Thank God we're all in computing and not in biology. We'd all be doing vivisection all the time, I think. So we can see now we're doing the NFS ops over there, and I'm just going to click on that, and let's just zoom in here. And of course, now it's actually done. So what I want to actually do, and this could be exciting. I've never actually done this before in this box, but let's be exciting. So what I'm going to try to do is compile Postgres, because MySQL wanted me to log in first. All right, so let's see. We'll run configure there, and we can see we're doing work. That's humping along doing work. OK, and we're seeing, we're doing some number of ops. By the way, just a quick aside about how this actually works. How am I actually displaying the graphics? I am not using client-side Flash or SFIGs or what have you. I found that stuff to be way too primitive. It was too invasive. It was too slow. I had a lot of problems. I also did not like the fact. I think Macromedia really screwed up Flash in a lot of ways. I mean, I think that Flash actually, if they had open source Flash in 2005, 2004, that's what would be the ubiquitous standard. But they didn't do that. So anyway, I didn't want to use those technologies. So what am I actually doing here? Because some people, what sort of graphing package are you using? I'm using C and libping. So what we're doing is actually, I'm just in C generating these pings dynamically using libping. And because it is just drawing a graph. I mean, it ain't that hard. I don't know why everyone wants to find some third-party package to just draw a goddamn graph. I mean, you can do that, right? I mean, you went to grade school. And OK, it's a little harder than that. I mean, admittedly, you got to anti-alias and do a bunch of crap like that. But it's not that hard. So I draw these things in pings. I draw the pings on the server and then give you a reference to the pings, and the browser goes off and fetches the pings. And what it ends up being really snappy, very low CPU utilization. So I can have lots and lots of graphs going, and we don't actually drive that much CPU at all. And it's very snappy from the client's perspective. So that you can be over a really slow link. So this data is not actually moving across the wire. The only thing that's moving across the wire is the actual graph itself. OK, that's done. And now things get really exciting. Will you make? Who knows? Well, you'll do something. You're doing work anyway. Are you doing actual? Oh, yeah, I need to catch up. Yeah, I paused it. Thank you. OK, so there we go. It's off, chugging, doing work. Great. So this is nice. This is, it's whatever. It's real time and so on. And you don't necessarily have that in a lot of other systems and blah, blah, blah. But ultimately, this is just the metric, right? This is actually, we're not actually getting to DTrace at all. We're just basically graphing a number, right? And this is more the kind of the happy or sad, albeit with slightly more texture to it. What I want to be, you are not done. OK, good. Whew, thank God. was about to say, I'd be very disappointed in VMware if it somehow managed to perform well right now. So we can see, and you better not finish up, by the way. Okay, good. Yeah, all these pauses are making me nervous. You chug over there. So what I want to know, actually, though, is in terms of this number of ops, is this what I would expect or not? I don't know. I want to be able to ask some really basic questions about this, like, what files am I serving and to whom? That seems pretty basic. We're talking about NAS, right? We serve files to machines. How hard is that? And yet, there is no storage box on the planet that can answer that question. That's embarrassing. Right? So you can go drop $1 million with NetApp or EMC or whomever you like, and go try to answer this question. And if you're lucky and you've got a lot of throw weight, you'll end up with a bevy of support engineers chasing their tails for 3 weeks to basically tell you, I don't know. I mean, they'll be discussing things like going through Snoop traces and so on, and they may be able to come up with some vague answer, but it's definitely the ugly way, right? They're trying to figure out what you ate for lunch by going through your fecal matter, which is not not a recommended way to do it. But the reason, by the way, that they can't answer these kinds of questions is because they don't have DTrace, right? Because you cannot keep, for example, per file information on the fly. It would be too expensive. But with DTrace, we can do that. Because with DTrace, we can dynamically instrument the system. And if I click on this power drill icon, and it looks like a hairdryer with a bad attitude, but trust me that it's a power drill, I can drill down by type of op, by client, by file name, and so on. So let's actually drill down by file name. Yes, you keep doing work. You keep doing work. Do not stop doing work, please. Thank you. And let's make that a bit bigger. And let's make that a bit wider. So now we can see what files we're actually accessing. God forbid that I actually know what my NAS box is doing. More importantly, I can take one of these files. Did you finish up? You're going to make it again. You're going to make it again. Make clean, baby. Oh, no, you're not done. Oh, yeah. No. Yeah. But all that work. Yeah, I don't care. Make it again. So what you want to know, of course, now we're going to see a completely different load here. Where's time zone? Does it actually do much? So actually, this is a little hard on the eyes because we're, just in terms of understanding what's going on in terms of the directory hierarchies, what's actually, I want to actually show this hierarchically. So now I can actually see the directory structure dynamically. So I can see dynamically the directory structure that's being accessed. And I can determine what the hell's going on. And what you may discover, what many of our customers have already discovered, even with something as basic as this, and this really is excruciatingly basic, and we're going to get more complicated here in the time we've got left. But even with something as basic as this, you may find that you already have found your performance problem. Your performance problem is, why is my dev guy talking to my production machine? Right? Now I know in your environment, everything is really strictly VLAN off, and it's impossible for a development machine to actually mount a share from a production machine. But the turkeys sitting next to you, they don't do that. They're just no attention to detail. Actually, the reality is most of us don't use VLANs, right? VLANs are great, but they're a giant pain in the ass, and they're a huge tax. And in most environments, your production, QA, and development can kind of get to one another, right? It depends on what your application is doing and so on. If you're in financial services and you've got regulatory constraints, it's different. But for most of us, we just don't have the time and the money to go do everything we'd want to do from a VLAN perspective. So you may discover, it's like, what the hell why is this machine accessing this? Right? And actually, to that point, let's take one of these that's being accessed a lot, and hopefully being accessed frequently, ADT, and I can actually drill down on that file by type of op, by client, by share, and so on. So let's actually drill down by client. Oh, no, it's stopped being accessed. Damn it. I need to get something that's, all right, let's get something that is still being accessed. What are you accessing now? It needs to be something consistent here, or we can drill down by client, but if it stops accessing it, of course, it's not very interesting. So let's see here. How about that? That looks, damn it. All right, let's hope this thing's not done with that. Let's see. I don't know, it's looking done. Damn it. All right, well, what you would say, of course, if this continued. Oh, hey, there we go, good. OK, there's my laptop, which is a relief. I mean, if that were like your machine, I would know that you're trying to fuck with me during my presentation, which would be a problem. But this can, of course, allow you to answer some really powerful questions. And by the way, from a DTrace perspective, let me just take you behind the scenes a little bit. And this is not something I would normally do. Are you done already? But let's go on to that machine. And actually, let's go on to, let me just show you the DTrace that's actually generated there. We'll SSH on there. So this is going on to the appliance now. And what I'm going to do is close your eyes. You didn't see that. You're not supposed to be here, but I'm here. But that's if you buy an appliance, don't do this, under penalty of death or something. OK, so let's go let's go back here. And it's not doing any work right now. That's why you don't see anything there. But let me just take another one of these guys. I'm going to close this thing, and we'll just drill down on this, even though we know it's not doing any work, and drill down on that by client. And OK, so this here, and let me make that bigger. So you can see that we don't present this to the user because this is basically debug output. But that is the actual descript that is enabled to answer the question. So behind the scenes, you've got dtrace. In this case, just with the predicate of, hey, if the path is the path that I clicked on, then I want to aggregate on the remote address. It's not very complicated. There's actually a lot of complexity under the hoods here, where this is what's called a translator, where we translate from internal data structures to ones that are stable. So you can actually rely on the script working even as we change the implementation of the NFS server. But that's kind of that's an orthogonal point. But so anyway, you can see how dtrace is actually being used under the hood to go do all this. And let me go back to my we'll iconify you. Yeah, and you're just doing it again. You were doing it again, my friend. Clean, thank you. Why am I calling clear? Because I'm used to, thank you. Everyone's a critic. All right, so let's catch up to real time again here. We can see it doing work, and let's actually. So this was kind of this was the state of analytics as we first developed it. This was after about the first year of development. We just kind of polished it up, and even with this, you can find things that are incredibly important that you can't find any other way. To give you a concrete example, some of you may know Don McCaskill is the CEO of SmugMug. SmugMug is one of our customers. Ended up being a very aggressive early adopter. Like many of our customers, ended up being a bit of an accidental early adopter in that they put the box in production, and then he had another box pop on him, and so he had to throw a bunch of load onto this machine that he was going to take off the next morning, but then it just kind of absorbed the load. Because we are actually delivering a much faster box than one typically has in the NAS space, it can generally deal with a pretty high amounts of load. So he ended up just leaving it there. So the next thing you know, his entire business is running on our box, which is not exactly what he intended. But that's how he got there. And one of the things, he used analytics, broke down by file, and what is something he sees? He sees one of the MySQL local cache files being written to on his NAS box. It's like, what the hell is that? It's like, this should not be, this is a local cache file, should never be written over NFS, breaks down by client, and the second he breaks down by client, he has this kind of oh shit moment, where he's like, oh yeah, right. And he remembered that something like a year and a half prior, he was in the middle of doing some surgery, and something was wrong with /temp on some local MySQL machine, and he had pointed this thing to his NAS box just so he could do the surgery, got the database up and running, and forgot to move it back. Don't! And especially for Don, for whom MySQL performance is the absolute essence of his business. Don't! So he fixed that immediately, and of course, performance, he saw a huge pop in, latency improved, the whole box improved. You don't need to print out another purchase order, perhaps. Perhaps it's just you got too much load pointed at the box. You got load pointed at the box accidentally. So that's an example of what I was talking about in terms of being able to see the wrong machine doing the wrong thing. The best way to make your system perform better, by the way, is not to make work incrementally faster, but to do less work. Don't do the stupid stuff. That is the way to make your machines much faster, your infrastructure much faster. So that was great. We had that out there, or we'd done this. But there was something that was gnawing at me in particular, or gnawing at us, and that is, OK, these ops are fine, And it's great that we can express this, but is a low number of ops a good thing or a bad thing? If you got 500 ops, is that a good thing or a bad thing? Depends. How long is each op taking? Right? If each op is taking 500 milliseconds, that's a bad thing. And you're doing 500 ops because the box can't do any more than that because that's how long each op is taking. But if the box isn't working that hard, or if each op is only taking 10 microseconds, 100 microseconds, what have you, who cares? Right? So we wanted to find a way to express latency. Latency is hard to express, though. And latency is hard to express for the same reason that you're trying to express a distribution. I don't want to just give you a number. Right? Because I could give you an average latency that is the latency of no operation. Right? It's the old average number of legs. You have a horse and a person, both in good health. The average number of legs is 3, but there is no 3-legged animal. Right? Same thing. So and you see that a lot. Now what are you doing? So what I want to do, Lochte not responding. There you are. Oh, OK. Don't do that to me now. So what we wanted to actually be able to do is to be able to understand what was going on in terms of latency. So what I'm going to do is, and if that, no, you're working. You seem to be working anyway. Lochte or something. I'm not sure what that. Yeah, if you want to stay afterwards, we can debug that. Let's see if it in the meantime, I won't load. We'll go debug that later. That's probably, to be honest, I hope that's probably a client-side issue, my experience with Mac client. Mac client is great. I love Mac. But, OK, so what actually, let's just do this. If you, that's not funny. All right, let's do this. Let me, instead of breaking down by ops, what I want to do is actually break down by latency. And what I'm going to see here, when I go back and put some load on the box, and we're going to go figure out what's going on here with, let's see if we can go, let's go connect to that, please. Now you're going to have stale file handles? Nope. Yeah, of course. OK, so let's actually do this. That seems fine. We'll do this. Let's do what works. All right, so what we can see here is the actual latency of the operations. And this is actually a much more, and you can see, of course, now that we're doing no work, we are presumably, and we could actually break down on those ops. Actually, let's do that. I would assume that now those operations, of course, are much, those should just be stats. Let's actually break down by type of op. And those are just accesses, right? So whereas before, we can see now the difference between when we were actually removing those files and when we are no longer removing those files. Let's try to make that again. See if you want to make it. Let's see if you can. And now we'll see, as we actually start doing the disk operations, we'll see that latency climb a bunch. What's going on in Lochte? OK, so let's actually, I want to change it to a, no, I'm done with that. I don't know what that is. All right, let's do this. We will go debug that later if you're curious to stick around. But what I want to go do, I actually want to do something different anyway. So let me just do a slightly more synthetic load, if you'll forgive me. And let's just make a file. Thank you. OK, so now I've done a much simpler operation of just making a file over and over again. And we can see the actual latency of the operation there. I don't know if you can see the clouds up there, but there are some, and it's amazing, 400 milliseconds is the scale there. Thank you, VMware. So what I want to do here is let's look now at the bottom of the stack instead of the top, and let's actually break down, let's look at the, excuse me for zooming in. No, don't do that. Thank you. There you go. Let's actually break down disk operations, and let's break down that by latency. So this is going to look at the bottom of the stack, and this is going to tell me how my disks are actually performing. And you can see here, even though we've got a virtual disk, it's still taking tens of milliseconds, or wow, 750 milliseconds, Jesus, to respond. That's like 1.2 seconds. Wow, that's a slow disk, a slow virtual disk.
And one of the things you can do here is if you're particularly curious about where are some of those outliers coming from, let's take, say 43 milliseconds, and I can then further break down by disk. And what I've effectively done here, by the way, is we are visualizing that quantize operation, right? Instead of being ASCII art, I mean, that is a little better than ASCII art. I mean, that's a little better. I still love the ASCII art, but it's slightly easier to. You can certainly see much more interesting patterns here, especially over time. And you can see some very, very strange things here. And if we have time at the end, I'll show you some of the really odd things we've seen just by looking at latency in this way. You can stare at these things for a long, long time and reason about them. And one of the things that we were doing, and let's Control-C that. One of the things that we were doing with a similar kind of workload, we had a new JBOD firmware that had arrived. And we were looking at disk latency just like this. Let me pause these guys. We were looking at disk latency. And one thing that we noticed with this new JBOD firmware is that the disk latency had some really serious outliers. Had like 800 millisecond outliers when we were pounding it with I/O. And this was a bit of a mystery. We didn't really know what was going on. But you could see that band very clearly. One of the nice things about visualizing the data this way is you'll see very clear banding when you've got some sort of issue going on. And we saw a very clear band at 800 milliseconds. And we just taken a new firmware drop for this JBOD, a JBOD which struggles with firmware issues. We're in a bit of a firmware crisis, by the way. We collectively, we humanity, are. That'll be the subject of my next rant, but not now. Corner me afterwards if you want to talk about the firmware crisis. Anyway, it was my natural assumption that the firmware guys screwed up again, and we're seeing these high outliers because of the firmware drop. Well, so we're looking at this output, and one of my colleagues was like, well, let's just break down, let's take some of the outliers and break down by disk. And I'm thinking, no, that's a stupid thing to do. Because we know if you're going to take the outliers and break down by disk, you want to show which disk has these 800 millisecond outliers. We know that it's going to be evenly distributed across all disks because it must be related to the firmware drop we just took. It's amazing. You would think by now, I mean, I've probably run DTrace, 100,000 times in my life? I don't know how many times. You think by now I would stop guessing because I'm so frequently wrong. Right? Indeed, that's the reason we developed DTrace, is because I know how frequently wrong I am, how frequently wrong we all are. And even as he was doing it, something like, this is a waste of time. But we get the answer back, and whoops, not a waste of time, because it's not every disk. It was one disk. There was one disk that was responsible for essentially all of those outliers. What the hell? What's that about? And then we're kind of like, what could be causing that? We're looking at the smart data. Smart data. It's like, no, I'm cool. I got no problems. No, you've got problems, my friend. I know you have problems. It's like, no, I don't know what you're talking about. It's like it's not physician, heal thyself. It's more like policeman, police thyself. And it does not work, needless to say. The smart counters are often 0 for drives that we know are behaving strangely. What the hell is going on? Well, so someone finally is like, let's go look at the drive. I'm like, no. You're going to go look at the drive? What do you think? There's a raccoon that's chewing on the drive? I mean, what are you talking about? What, it's going to be on fire? I mean, that's a dumb idea. But I didn't say that because it's I didn't have any good ideas. I had nothing but dumb ideas. So all right, let's do your dumb idea instead of my dumb idea. And in particular, we saw that, again, here we see that the disks are pretty evenly distributed, which is a relief. That's what you'd expect. But if we look at let's look at one of those samples there, and let's hierarchically, that should be pretty evenly spread. I wouldn't expect VMware to be biasing its latency towards any one disk. It's a little bit biased maybe, but not too much. But in this case, it was all one disk. Well, so how do we figure out where HDD11 is in the system? Well, this is one of those problems that the delivering of an appliance gives us the luxury of solving. If we go over to our maintenance hardware view, we can actually get a physical view of the machine. Now, this is a virtual machine, so that's just kind of a made-up machine. But if you go onto one of your appliances, you will find that this is an actual image of your machine, and you can go click on the disk, and it will highlight it. If you have a real machine, you could then go click on, there's a button out here, you can actually light the LED on the disk, which you should primarily use as a way of screwing with your colleagues. Can you just go into the server and you need to change the disk with the LED that's lit? And then you can be like, da-da-da-da-da. They're kind of there being seeing the LEDs are It's like, what's your problem? I just told you to change the disk. It's like, the LED was changing. Oh, the LED was changing. Yeah, okay, got it. Oh, that makes sense. Sucker. That's really what we're trying, that's always what we're trying to develop, is really preeminent frameworks for elaborate pranks. That's really what is the mother of truly all invention. But you can actually light the LED. And so we did this, we lit the LED, and sure enough, a raccoon had broken, no, I'm kidding. So we go in there, and we find the lit drive, and we pull it out, and again, I'm a total cynic or skeptic. I'm like, what the hell are we doing? Pull the drive out, and the three of us, like, I could feel the breath exit us, gasp. And we looked at the drive was missing 3 of its screws. It's like, whoa, raccoon theory comes back. Right? It's like, you're missing 3 of it. It's like, this is a vibe problem? I mean, it makes sense when you think about it. It's like, I mean, the screws are there for a reason. And I mean, of course, something that doesn't have any, that is not mounted has lost its mounting screws. And this, by the way, is not a drive that I put in, so the screws must have been there when the drive went in. Somehow the screws have presumably shaken themselves out. We're still kind of disbelieving it, and we put the screws back in. It's like, this is a vibe problem. And we put the disk back in, and it's a champ. 800 millisecond latencies go away. Wow, that was a loose screw. That's scary. And then we're like, oh man, we should have blogged all that. Like that was really interesting. Like the fact that we used analytics to discover a loose screw, like a real loose screw, not like you denigrating your VP, but actually a loose screw. All right. So let's go back in. Let's take the screws out, and we'll go take the screws out of the drive, put the drive back in. Of course, now the thing is a champ. It's like, oh god. Which makes sense, unfortunately. So if you've dealt with vibe problems in the past, vibe problems are very, very finicky. They often are, there's often an interference effect to it. You often have positive interference. You distort the system a little bit. This is why you make vibe problems go away by changing the system, which is really, makes them very, very difficult to debug. So if you've dealt with vibe problems, unless it's an actual bad component that's inducing the vibe, they can be really tough to debug. So we take the screw out, of course, and it's like, all right, well, this makes sense, but it's so frustrating. So then we start taking the screws out of every bracket. And we've got so every drive is just like sitting there on its mounting bracket. You're like, come on, damn it. And still nothing. You're like, oh, stupid drive. Why can't, you cannot behave so many other times. Why can't you just misbehave when I want you to misbehave? So we were talking about this, my colleague and I were talking about this, and one of the things that we were talking about, just kind of went over to lunch. So we had we're all in the wrong business, by the way. We should all be in the data center fire suppression business. That's where I don't know if you actually cut your checks to Fenwal, you pay like $50K for a canister of gas. That is where the real money is made in our industry, by the way, in terms of fire suppression. And we had inherited, we had an old MCI data center that I swear was cleaned out by ex-MCI employees who had the car running out front because they just sliced through the cables, took all the infrastructure out. But honey, they were professionals, they took the Fenwal. Somebody knew what they were doing because they took that goddamn canister of gas. So anyway, so the FM200 is, and we had this ridiculously expensive data center fire suppression system, which was frenetically beeping with the everything normal, everything okay alarm. So it is literally, this is like, it's like all the things are flashing, everything okay, system normal. You're like, okay. Like, if the system is normal, maybe we can tone it down a little bit. Like, maybe you don't need to scream at me that the system is normal. And it turns out, of course, it's a firmware bug, their firmware bug, that isn't everything. But so we were wondering, like, you don't think that, like, this thing has been just screaming in here? Like, do you don't think that's related? Nah, it can't be related. But actually, hey, wait a minute, we could use sound to induce this. So he's going to go back and write just a little program on his laptop, using Python or whatever, to just go generate a bunch of sounds. And he's going to and see if he can get sound to induce the latency. So he goes into the lab, and I go back to work, which is on the next office over. And like maybe 3 minutes later, Brendan comes running in. This is not a guy who runs in the course. Like, if he's running, you run in the same directions that he is running. This is not someone who usually runs in the office. And he says, you got to come see this. And I'm like, okay. So he goes running back, and I'm like, what the hell is going on? So I'm running after him. And he's got this display up. Looks very similar to this, where he's looking at ops per second and looking at latency, and in terms of disk latency, and zeroing in on disk operations higher than, in this case, I think it was 500 milliseconds. So he props me up in front of this thing, and then he goes in front of the JBOD. All right, watch that. He just goes, "Brah!" from like 6 inches away. And all of a sudden you see like, boom, you see this huge latency outliers. And I'm obviously laughing, and we're like, okay, like we gotta go put this on YouTube. So I grabbed the camera. Fortunately, he had a camera there. We grabbed the camera. We just did one take. And so I don't know if you happen to see this got viral. We did this over the Christmas holiday, and there was, he and I were the only ones in the office, and apparently you all were at home wondering what the hell to do with yourself with so this ended up. I thought this would be seen by a couple thousand people. We put it on our blogs or whatever. It turns out this has been seen over 500,000 times. It has been seen more than any media ever put together by Sun. As it turns out, it's more than they've got the entire list. It's more than the next 10 put together, and I feel a little bit awkward because the one thing is the media, the marketing VP is just like, hey, it's been really successful. We do wish you had said the name Sun Microsystems in there. Like, did we not? No, I guess we didn't. I'm sorry. And by the way, the reason that this was, if you saw this video, and you can, YouTube, by the way, now thinks that I'm some sort of big-time content pimp. Every time I go to YouTube, it invites me to participate in the revenue sharing program. Because it's like, something seen by 500,000 viewers, not necessarily that impressive. Something seen by 500,000 viewers that does not infringe on anyone else's copyrights and does not involve kittens, that's impressive. And so they're like, hey, why don't you join our content? And I'm like, listen, I am a one-trick pony. I'm done. I'm one and done. I got nothing else. We just got Brendan shouting at JBods. That's it. And if you look at that video, by the way, you'll notice that the camera is shaking a little bit the second time he does it. That's because I'm still laughing. I'm only seeing it for the third time. And the reason, by the way, that got so many views, I think, is not. It's showing an interesting issue. That my one regret of the video is not the lack of the Sun Microsystems name. My one regret of the video is that we did not explain how we got there. So if you saw that, you would just think like, well, I don't scream my data center too much. And all right, so when I shout at the data center, I need to go shout at some my SSDs or whatever instead of my spindles. But the way we got there is not by just randomly shouting at infrastructure. The way we got there, a problem which you generally don't have, the way we got there is the loose screw, which is a problem that you probably do have. We all have loose screws, right? You got a screws in your spindles. There's a screw loose in there somewhere. And if it's not a screw, it's a cable. We found this with cable. We found this with doing same kind of analysis. Found a gig E cable that was negotiating down to 100 megabit because it was a bad cable. Good luck finding that, right? Very, very hard to find that kind of stuff. It really stuck out when we were looking at latency and looking at bandwidth. We could isolate a single NIC. So you can find lots of physical problems in your infrastructure by being, and the ability to visualize DTrace has taken it to the next level. We are now, and I use DTrace when I'm solving a problem that requires that arbitrariness. It requires me to, and I use DTrace every day to do that. But if I just want to visualize the system, this is the way I do it. Analytics is definitely my preferred vector. And just one footnote, and then I'll open it up for questions. But one final footnote on that video. I would love to say that video was watched by so many people because they really, they appreciate the foundation technology and DTrace and blah blah blah. That's not it. The reason people watch that video is because we always have wanted to anthropomorphize the machine. Right? And in particular, think of your parents, right? When they're not able to log into Yahoo, it's always like, oh, the computer's mad at me. It's like, it's not mad at you, Mom. The caps lock key is on. The caps lock key is mad at you. That's why you can't log in. All right, maybe that's too personal a story. It's a lot of issues, I guess. It's from Mom picking up when I'm on the BBS, Mom. All right, sorry. Back in the day, for you youngsters, we'll talk about what that is later. But people always want to anthropomorphize the machine, and the whole idea that if you go shout at your infrastructure, it's sad or mad, and so it gives you bad latency. People just love that idea. It's like, well, don't shout at your JBods. They obviously don't like it. So I think that's why that got so many hits. Fortunately, we don't have to anthropomorphize the machine. You feel free to torture your machines as much as you want. We don't need to anthropomorphize them. But so that gives you an idea of what we can do. I didn't get a chance to. I want to open it up for a couple minutes of questions. There are other aspects of this facility that we didn't get to. But suffice it to say that every element of this facility, of the analytics facility in the SunStorage 7000 series, every aspect of this facility is here because we needed it to go understand performance. So we do not just kind of invent things for their own sake. We very much invent them to help you solve your problems, because we're trying to solve your problems alongside you. So, with that, I'll thank you very much and open it up to questions.
How you doing? That was fantastic. Thank you. I was wondering, we have a couple 4500 series that I would love to lay that tool down on top of. Is that available for that?
Yeah. Did someone put you up to this? This is always the first question. It's a totally natural first question. It's like, so when can I get this for my other end machines?
I mean, it's Sun. Come on.
Yeah, it is Sun, right? Same company. So yeah, I mean, I would love to be able to do that for you. Unfortunately, so with the 4500 in particular, that is not supportable by us as a NAS appliance for some in-depth reasons that we can get into, and there's just not enough of a business case there, which with my new masters we actually care a lot more about, as it turns out. It's like, oh, we're actually going to look at how we make it and lose money? Wow, okay, that's foreign. Okay, let's do that. We'll try it your way for a couple of decades. See if it works out any better. There's not really a business case there. I think what we want to do, my vision for this is not just as a NAS appliance. Because it's like, when you have this, what's specific to storage about this, really, right? Like, why can't I have this on my compute nodes? Why can't I have this on my networking nodes? We went after the NAS space because it was the one that was most obvious to us. It was the one in which there was most room for disruptive innovation. It's the one in which you were paying way too much, frankly. We can come in with a much cheaper product. I want to take this to all those other spaces. So the vector for that is going to be, and I wish I could tell you it's going to happen in the next 6 months, but it's probably going to take longer than that to get out. The vector for this is going to be a server appliance, if you will, where you are effectively running this guy in the global zone, and then you're pumping out zones that look like however you want to look like. And then you can run it, you can kind of run it however you want to. The other thing that I want to do, ultimately, in the fullness of time, I do want to open source all this stuff to allow you to run it yourself. But I wish I could tell you that I'm sorry. And I would like to do it. It's just the business case isn't quite there, and it would be expensive for us to do.
Thank you.
Yeah, thank you.
Hi. With the 7000 series, you mentioned that you mostly did it for the NAS market. Have you considered getting the 7000 to be SAN capable for FC?
Yeah, you bet. When we first released it, we had iSCSI and NAS, but I'm not religious about this. I think that people, in terms of, there was a while where it was kind of like NAS versus SAN was kind of a religious war. I've got no dog in the fight, so I want any protocol you want to be able to access the box, we should be providing to you. So to that end, actually, when I'm not here, when I'm not responding to Doug's emails, what am I doing? I am working on the FC target, which we will ship in our Q4 software release. Q4 is calendar Q4, so that'll be under the tree this year. Christmas present from Fishworks is going to be the FC target, and boy, it's given me some complicated emotions, I have to say, because I say that I don't have a dog in the fight, but I'm always kind of a bit of a NAS guy. I think that there's a bit of a kind of a Unix mainframe kind of a NAS SAN thing, a little bit, and I've always been like, well, and especially with the observability, I love being able to see the file. I mean, to me, the reason to use NAS is because I can actually see what files are being accessed, right? But God damn, is FC fast. I mean, it is. I see the appeal. That now that we got it working, it's like that, because unlike with Gig E, where the hardware offload is a really complicated operation, doesn't always work. It's got a lot of problems. I mean, it's the strength of IP. It's dynamic and so on, but you absolutely pay a performance penalty for it. No question. And on FC, it's static. It's a pain in the ass to configure. It's a little more expensive. Blah 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 blah. But when you've got all that done, man, it's a champ. So we're pushing tons of bandwidth through FC, so we're really looking forward to bringing it to market. And you're going to have all your analytics, too. So you'll be able to look at your FC operations by offset, by latency, by initiator, and so on. So yeah, if you've got more details on that, see me.
So as a follow-on to that, how about FC over E?
FCOE. Boy, normally that's like is QLogic or Cisco paying you like $500 to ask that question. I would put FCOE in the IP over FC bucket. And I think I'll leave it at that. I think I'll just leave it at that. I think I'll just put that one out there. Next question. Okay, interesting. Well, with FCOE, so I do think I guess I'm not going to leave it at that. I do put FCOE in the IP over FC bucket. In that I think that it is something that we can do, but I don't see it making economic sense. If FCOE did not require a switch upgrade, then sure. But like, you got to do a forklift upgrade of all your switches. I mean, of course the vendors want you to do it. It's like the vendors are like, man, I got to go remonetize you. It's like, what's this verb, remonetize? I don't think I like this so much. Right, because they want to go in and replace all your infrastructure. But to me, FCOE, what I see with FCOE, I see the economics of FC and the unreliability of Ethernet, which is not a really good combination, actually. And by the way, 10 gig, Ethernet got a bit too good of a brand name in the 100 meg to 1 gig transition. Because from 100 meg, we all saw 100 meg to 1 gig, and when 1 gig came out, it was first optical, right? And it was optical for a year or two. But then good old 1000 base T came out, and I got my good old Cat5 cable, and I can still make the cables myself, the way God intended, right? And everyone's like, so everyone thinks like, oh, that's Ethernet. Ethernet is, I wait a couple of years, then I can use Cat5 cable. And that was not a correct inference. That was false deduction, because from gig to 10 gig, you ain't doing that over Cat5, ever. That's physics. You're not doing it over Cat5. You're going to do it over, people are like, oh, but you're doing it over copper today. It's like, yeah, do you have one of those copper cables? You're like, I mean, it's a garden hose, right? It's an IB cable. And that's what it's going to be, by the way. That's what it's going to be. The cabling, like your 1 gig, your Cat5 cabling is not going to your high bandwidth computing, ever. So the idea of, I think Ethernet gets romanticized because, yes, the ports are cheap. The ports are cheap because it's not optical, right? It's like, it's a freaking RJ45 jack. You're not doing that ever, ever, ever with 10 gig. It's either going to be optical or it's going to be, garden hose. So to me, Ethernet, once you give up that kind of bias towards Ethernet, it kind of loses some of its romanticism. It's not the 100 meg to 1 gig transition was cheap. 1 gig to 10 gig, I don't think so much. And then you start looking at other technologies like, well, as long as the cabling is going to be optical or garden hose, then IB starts to become more interesting, right? IB is kicking the shit out of Ethernet from a bandwidth perspective. We're already, QDR, we're already at 40 gigabits per port. And, 10 gig is struggling to get 10, right? What's that? And 80's coming. 80 is coming, and we're going to 16 gig FC, too. And Ethernet is stuck at 10 gig. We're going to 40 gig. It's like, yeah, okay, yeah. When are you doing 40 gig? Oh, 18 to 24 months. 18 to 24 months, by the way, do you know what 18 to 24 months means? 18 to 24 months is just like, I appreciate that you think this is a problem, but I have no intention of dealing with it in the foreseeable future. 18 to 24 months. 18 to 24 months, my friend. Because you can't see that far into the future, I don't think. Unless you got, it's certainly not on a NIC. So that to me, actually, has anyone here deployed FCOE? That's kind of what I'm talking about. Is anyone here, do you have it in the lab at all? Are you looking at it? Okay, yeah, all right. Yeah, so anyway, we'll see. If FCOE does become an issue, we're ready to go. Because to me, I am not in this, I'm not going to be religious about bandwidth. So if FCOE, I don't see how it can happen, but if it does happen and FCOE becomes, the economics make sense and everyone's going to FCOE, we'll go to FCOE inside of 4 weeks because I got all the infrastructure to do it. I got the target done. I just don't want to ship it because I don't want to support it because I don't want to have to deal with a 5% performance regression on FCOE when there are no hands going up on people using FCOE. So, all right, that's enough said about FCOE. Other questions? Super. Thank you so much for your time.